noticed something, didn't we, when we were doing function algebra to those polynomials? And in fact, there are a lot of things that we might notice about function algebra and polynomials. The first thing we notice is that the polynomial functions are all things that we can build by taking linear stuff and constant stuff, and then adding, subtracting, and multiplying. Remember, we're taking powers, but we're taking positive integer powers, which is just repeated multiplication. Just as an example of this, here's just some random polynomial. And we're going to see how we can build this from linear functions and constant functions with just addition, subtraction, and multiplication. There are lots of ways to do this, but we might say something like, let's let f of x be 2x, g of x be just x, and then I'm going to let h of x be the constant function 7. Then f times g of x is 2x times x is 2x squared. And then I think I can build my polynomial by taking f times g and then adding in another f and then subtracting h, because that'll be 2x squared plus 2x minus 7, which is what my polynomial was. Now, that might have seemed a little bit weird. Why did I pick exactly that way to do it? Were there other ways? Absolutely, there were other ways I could have done that. There are lots of ways in general that we can break a function apart. I picked that way because it jumped out at me as the most obvious. The key idea here is not that there's some special way to break down a polynomial, but rather that we can break down polynomials as the result of adding, subtracting, and multiplying linear stuff. This gives us something about the domain of a polynomial, though. The domain of linear stuff is all real numbers. The domain of a constant is obviously all real numbers. So if all polynomials can be built this way, the domain of a polynomial function is always all real numbers. In notation, if p is a polynomial function, then the domain of p, we can use that Blackboard caps R symbol, or we can write negative infinity to infinity if we want interval notation. This is neat. The domain of a polynomial is all real numbers. We've also talked about adding, subtracting, and multiplying polynomials. And we've discovered that whenever we do that, we get another polynomial. This gives a cool property of the polynomials called closure. The set of polynomial functions is closed under addition, subtraction, and multiplication. That is, if we have two polynomials, we add them, subtract them, or multiply them, we get another polynomial. Crucially, this is not true for division. And in fact, it's kind of the mirror of the way that the integers work. If we add, subtract, multiply two integers, we're going to get another integer. But if we divide two integers, we might get a fraction. If we add, subtract, or multiply two polynomials, we get another polynomial. If we divide two polynomials, we might get a new kind of thing that we're going to meet very shortly.